Types of sets.
Now we will learn different types of sets. The first type is a singleton set. Observe the following sets. 4 is an element of set A. 0 is an element of set B. 3 is an element of set C. And 7 is an element of set D. February is an element of set M. What do you observe in all these sets? The answer is they all have only one element and hence they are called singleton sets. A set containing exactly one element is called a singleton set. The next type is an empty set. Consider these sets. N is a set of all x such that x is a natural number between 4 and 5. P is a set of integers whose square is a negative number. Both these sets N and P have no elements and hence are called an empty set. A set having no element is called an empty set or a null set and is denoted by a curly bracket without any elements. It is also written as phi. In the examples above, we write N is equal to empty and P is equal to empty. The next type is a finite set. Observe the following sets. 1, 2, 3, 4 and 5 are the elements of set A. B is a set of all students in your class. In both these sets, we can count the number of elements of the set A and B. Hence, they are called finite sets. If the counting process of elements in a set terminates, then such a set is called a finite set. An empty set is also a finite set since the counting process of elements terminates in the beginning itself. The next type is the infinite sets. Observe the following sets. 2, 4, 6, 8 and so on are the elements of set A. 0, 1, 2, 3 and so on are the elements of set W, that is the set of whole numbers. The set of rational numbers Q is equal to all P upon Q such that P, Q belongs to integers and Q is not equal to 0. In all these sets, A, W and Q, the counting process does not terminate. Hence, they are called infinite set. A set which is not finite is called an infinite set. Students, note that an empty set is a finite set. The set of natural numbers, whole numbers, integers, rational numbers and real numbers are infinite sets. Answer the following questions. State which of the following are singleton sets. B is a set of prime numbers less than 3. C is equal to the set of all x such that x plus 5 is equal to 4. D is equal to the set of all x such that x is a square root of 1. The answer is as follows. 2 is an element of set B. -1 is an element of set C. 1 and -1 are elements of set D. Sets B and C have only one element. Hence, they are singleton set. State which of the following sets are empty. E is a set of all A such that A plus 3 is equal to 3. F is a set of all B such that B is an even prime number greater than 2. G is a set of months having 32 days. The answer is as follows. 0 is an element of set E. Set F and set G have no elements, hence they are empty sets. Which of the following sets are finite or infinite? A is a set of all x such that x is a point on a line. B is a set of all x such that x is a factor of 36. C is a set of all x such that x is a multiple of 6. D is a set of vowels of English alphabets other than A, E, I, O, U. The answer is as follows. A is an infinite set since there are infinite points on a line. 1, 2, 3, 4, 6, 9, 12, 18 and 36 belong to set B. Hence, set B is a finite set. 6, 12, 18 and so on belong to set C. Hence, C is an infinite set. D is an empty set. Hence, D is a finite set.
Equal sets.
Now we will learn about equal sets. Observe the following sets. A is a set of all x such that x is a letter in the word eat. E, A and T are elements of set A. B is a set of all x such that x is a letter in the word ate. A, T and E are elements of set B. 1, 2, 3 and 4 are elements of set C. D is a set of all x such that x is a natural number less than 5. Therefore, 1, 2, 3 and 4 are elements of set D. You may have observed that sets A and B contain the same elements. Similarly, sets C and D too contain the same elements. Two sets are said to be equal if they contain the same elements. Hence, sets A and B and sets C and D are equal sets. Symbolically, we write it in the following manner. A equal to B and C equal to D. If sets E and F are not equal, we write it in the following manner. E not equal to F.
Question. Let set P be all x such that x is a letter in the word cataract, and set Q be all y such that y is a letter in the word tract. Show that P is equal to Q. We write the given sets in roster form. P consists of elements C, A, T and R, and Q consists of elements T, R, A and C. Both the sets P and Q have the same elements. Therefore, P is equal to Q.
Venn diagrams.
Venn diagram. Here we use diagrams to explain a concept. It was introduced first by Leonhard Euler, but the idea was used and developed by a British logician, John Venn, to study sets and operations on the set. Look at these figures. A, B and C are elements of set A. 1, 4, 9 and 16 are elements of set B. 1, 2, 3 are elements of set C. 2, 4, 6, 8 and 10 are elements of set D. These figures represent set A, set B, set C and set D respectively with the help of a square, rectangle, triangle and a circle. And these figures are called as Venn diagrams. In a Venn diagram, a closed figure such as a square, rectangle, triangle, circle, etc. are used to represent a set. The elements of the set are represented along with dots in the diagram. The name of the set is also written. Represent the following sets with the help of Venn diagram. A is the set of alphabets in the word set. The answer is as shown. B is the set of all x such that x is a digit in the number 1, 2, 5, 7, 8. The answer is as shown.